Hello, welcome back to Uncommand Online Academy. Here we have a repeat class on the application of Pythagoras theorem. And as you know, we've done this lesson before. We've talked about the application of Pythagoras theorem, but in this class, in this lesson, we want to make some concepts clearer for you to be able to solve any problem about the application of Pythagoras theorem. This means that we are going to be solving a lot of examples in this lesson, so pay special attention. Now, we say that we can use Pythagoras theorem to solve any problem that can result to right-angled triangle. In real life, there are some things that if we want to measure it, that thing will give us something that looks like a right angle triangle. Once anything results to a shape that looks like right angle triangle, we can use Pythagoras theorem to solve the side or to get anything we want from it. For instance, if we want to measure the height of a house, we can use Pythagoras theorem to get it. If we want to measure the height of a tree, we can use Pythagoras theorem to get it. Why? Because the tree and the ground, two of them are perpendicular to each other. Anything that makes angle 90 degrees will give us a complete shape that will result to right-angled triangle. And once we have right-angled triangle, we can use Pythagoras theorem to find any of the sides that we are looking for. If this is a tree and this is the floor, the contact between the ground and the tree will always result to 90 degrees. So they are perpendicular to each other, and because they are perpendicular to each other, we can always join this side to calculate any of the sides that we are looking for. Assuming we have a house, the house and the floor, this is the height of the house and this is the floor, it results to a perpendicular sign here, and which means that you can join this place to get any of the sides we are looking for. Now, take for instance, assuming that this is your house, this one is your house, somebody's on top of your roof, and the person throws a rope, then the rope will fall like this down. You can actually measure the height of the house, since we know that the contact between the floor of the house and the wall of the house is 90 degrees. So we can draw this thing and get it to the place where the rope falls. When we get there, if we know this distance and we know the length of the rope, we can now find the height of the house. If we already know the height of the house and we know the distance here, then we can also get this length of the rope. So whichever one we are looking for, if we know the height of the house and we know the length of the rope, we can find the distance between the house and where the rope falls. Now take another example. Assuming that you have a pole. You know that when we have our flag in the school, when we stand the flag, we always have one long rope that holds the flag so that it will not fall. Now, if we want to measure the height of the pole, what we can do is this. If we know the length of the rope, we just check the distance between where the rope is pegged. They will always peg the rope somewhere far from the somehow far from the pole, then we check the distance between the pole to the place where the rope is pegged. When we calculate the distance between two of them, and maybe we already know the length of the rope, then we can find the height of the pole, because this floor and the pole, they are perpendicular to each other, so this makes angle 90 degrees. Now you also can use this thing to find diagonal of maybe a land. Now assuming that you have rectangle a rectangle, maybe we know this side A and we know this side B, and maybe this is the diagonal, the length that passes through the two edges of a shape, one edge here, another edge here. Now let me say that this place is A, okay, let's say that this place is A. Now we know that this place is B. For a rectangle, each of the edges is 90 degrees. So that means that if this place is 90 degrees, now this place is going to be, assuming that we call this place C, so this place becomes the hypotenuse because we have angle 90 degrees there. So we can get the diagonal if we know the two sides of the rectangle. Now assuming we also have something like square, in square each of the angles is also 90 degrees. For square, each of the angle is 90 degrees again, but in square, each of the sides are equal. So assuming we know this place A, this place is also going to be A. Now if we draw a diagonal, now and we call it C. Now that means that if this place is A, this place is also A. Now the diagonal C, or yeah, C, let's call it C. Now this place is A also. Now what it means that C squared is equal to A squared plus A squared. That is the two adjacents. Now we can also use this thing to bring it to a real life situation in which we have maybe a piece of land, and the piece of land is rectangular. If you have a piece of land that is rectangular, this is a piece of land, like when we were in school, when we were in primary school, we used to pass people's land. Any place you see that place will be a shortcut to your house, you just divide the land and move. Now assuming that we have this land, students can create a pathway through the land. Maybe from this edge, this place will get to their house quicker. Now they divide the land into two and create a way inside the land. Now assuming we already know this side as A, we know the length of this place and we know the length of this side of the land, we can calculate the length of the pathway we've created inside the land. Maybe let's call it C. This place is A, maybe this place is B. Assuming that the land is rectangular. Now this place may be C. Let's call the pathway we created inside the land C. Now this place, the edges of a rectangle is 90 degrees. So this makes a right angle triangle. So we can use the Pythagorean theorem to find the length of the pathway we created inside the land. So these are different ways we can apply Pythagorean theorem. In another way, if we have somebody moving through the cardinal points, we can also use Pythagorean theorem to calculate the person's distance. Take for instance, now we know that cardinal points we have, this is north, this is south, this is east, and this is west. Now take a situation where somebody is moving from north and coming down to south. From north like this, the person is coming to south, and then he gets to a place, he starts going to the east. If we draw cardinal points, this point is 90 degrees, this point is 90 degrees, this point is 90 degrees, this point is 90 degrees. Let me draw it very well. I say that in cardinal points, if we have, this is north, north, south, east, and west. If you have a cardinal point like this, the contact between north and east is 90 degrees. The contact between east and south is 90 degrees. The contact between south and west is 90 degrees. And the contact between north and west is also 90 degrees. So if somebody is moving from north to south and then turn to east, it means that the person will make angle 90 degrees. If somebody is coming from east and coming towards west, and at a point the person start coming to south, that means that the person will make angle 90 degrees. Now if somebody is coming from south and going up to north, and at a point the person moves to the west, that means the person will make angle 90 degrees. If somebody is also coming from west and going to the east, and at a point the person starts going to the south, the person will also make angle 90 degrees. If somebody is coming from the west, the person is coming from the west, and at a point the person starts to go up to the north, the person will make angle 90 degrees. The same way, if the person is coming from north and at a point the person starts to come to the west, the person will make angle 90 degrees. So once we have angle 90 degrees, we can complete the shape to have a right angled triangle, and we can now find any of the missing sides. Now let's solve examples. Example 1. Example 1. If we have that a ladder of length, 5 meter is leaned. To lean means to place it, to be lying on a vertical wall. If the top of the ladder is touching the end of the wall, or the roof, and the ladder is 2 meter away from the wall. Now calculate the height of the wall. Now we have a ladder, we have a wall. We start with the wall. There is a wall. Now we place a ladder, leaning it on the wall, and we are told that the top of the ladder is touching the end of the wall, so it's standing on the roof of the house or the wall. Now the distance between the house, this is the wall, and this is where the root of the ladder or the bottom of the ladder. The distance between the wall and the ladder is 2 meters. This is 2 meters, and we are told that the ladder is 5 meters. Now we are asked to calculate the height of the house. Let's call it x. Now we know that the house and the floor, they are perpendicular to each other. That means that we have something like this. And now we can now say that this place is the hypotenuse. Now we can calculate the side x, that is the height of the house, by using Pythagoras theorem. So what we do now is that we say that this side, which is the hypotenuse, the square of it is equal to the square of the two adjacent sides. That means that 5 squared is equal to x squared plus 2 squared. Then 25 is equal to x squared plus 4, and x squared is equal to 25 minus 4, which is equal to 21. Now this means that x is equal to root 21. Our x is equal to root 21. So that is the answer. So here is root 21. We have calculated it. So we have calculated the height of the house without using any tape to measure it, just because we know the length of the rope, the length of the ladder, and the distance between the ladder and the house. We apply Pythagoras theorem and we calculate it. So even your house, you can go and measure the height of your house by just bringing a ladder, lean it and make it to touch the roof of your ladder of your house. Then check the distance between the bottom of the ladder, and then when you come back, you check the length of the ladder that you used to lean on the wall. When you get the distance, the length of the ladder, and then the distance between the floor, between the ladder and the house, you now apply Pythagoras theorem to calculate the height of your house. So that is a real life application of Pythagoras theorem. Example 2. Now assuming that we have this example 2, a boy travels 5 meters from the north to the south, 5 meters to the south, and then 2 meters to the east, 2 meters to the east, full stop. Calculate his distance to the north. Calculate his distance to the north. Now how do we solve this? Now this is north, n. Now the boy traveled down to the south and covers a distance of 5 meters. To the south. This is 5 meters. And now suddenly the person starts going to the east and covers a distance of 2 meter. Now the question is asking us to calculate the distance between the boy is now here, and the north, which is here. So the distance is going to be this line that covers this shape. That is the diagonal there. So let's call it x. This is the distance between the boy and the north. This red line. So to calculate for x, this place is the hypotenuse because it is from the cardinal points coming from north to east, makes angle 90 degrees. Now that means that this x is the hypotenuse and the other sides are adjacent. Now x squared now is equal to 5 squared plus 2 squared. X squared is equal to 25 plus 4. Then x squared is equal to 29 and x is equal to root 29. So the value of x is root 29. So the person is root 29 meter away from the north. The distance between the person and the north is root 29 meter. So that is how to calculate this. Example 3. Example 3. If you have that a pool of 5 meter casts its shadow 2 meter away from the pole, calculate the distance between the top of the pole and the shadow. Now look at how we are going to solve this. This is a pole. Now the shadow of the pole, someone sees it here, and this place is 2 meters away from the pole. Now we know that the pole itself is 5 meters, the height of the pole. Now they are asking us to find the distance between the shadow and the top of the pole. So that is this line. We complete it. The shadow is lying on the floor and the pole is touching the floor. So two of them are going to make a perpendicular sign. So we have this place as 90 degrees. So if this place is 90 degrees, then we can call this place x, and that means that x squared is equal to 5 squared plus 2 squared. So x squared is equal to 25 plus 4, and x squared is equal to 29, and x is equal to root 29. So this place, the distance between the shadow and the top of the pole is root 29 meter. So that is how to solve this one. Now we look for, let's solve another example. If the example 4, if they construct the equation this way, that a rectangular A rectangular piece of land. A rectangular piece of land measures 5 meter by 2 meter. If a pathway is made diagonally if a pathway is made diagonally across the land, calculate the length of the diagonal, or length of the pathway. Calculate the length of the diagonal or length of the pathway. Now, they say it's a rectangular piece of land. So we have a land like this. Now somebody decides to create a way inside the land, students and their trouble. Somebody's land, you are creating a road inside the person's land. Now we know that the land measures 5 meter by 2 meter. 5 meter by 2 meter means that one side of the land is 5 meter and the other side of the land is 2 meter. So we can now say the longest side of the rectangle is 5 meter and this side is 2 meter. Now let's call the diagonal or the pathway created x. So we have that x squared, since this is a rectangle, this place is 90 degrees. So x squared is equal to 5 squared plus 2 squared. Now x squared is equal to 25 plus 4 and x squared is equal to 29. So x is equal to root 29. So the length of the pathway created is root 29. I just decided to be using 5 and 2 to make our calculations easy for us. In the real distance equations, you may see different values. So this is how to calculate it. Very simple. Now, they can also give us another example like this. Example 5. Example 5, we can have something like a man on a roof, or a carpenter. They can say a carpenter on a roof throws a rope to the ground. If the rope falls 2 meters away from the house, 2 meters away from the house, calculate the height of the house, if the rope is 5 meters long. If the rope is 5 meters long. Now, this is your house, and somebody is on top of the house, a carpenter. He throws a rope from the top. The rope will fall like this, then to the floor. Now, they say that the distance between the house and the rope, where the rope falls, is 2 meters. So we join this place. This is 2 meters. Now, the length of the rope is 5 meters. They now want us to find the height of the house. So without using any meter, rule, or any tape, we can get the height of the house since we know the distance between the house and the rope, and we know the length of the rope, because the house and the floor makes a perpendicular shape, angle 90 degrees. So that means that this place becomes the hypotenuse, while the other sides are the adjacent. Now we can call this place x, and we now say that 5 squared is equal to x squared plus 2 squared. 25 is equal to x squared plus 4, and x squared is equal to 25 minus 4. X squared is equal to 21, and x is equal to root 21. So this place is root 21. So with this, we can get the height of the house without using any tape. So these are different ways we can apply Pythagoras theorem to get the height or the side of anything we want in real life. That is the application of Pythagoras theorem. I hope that this lesson has made all the concepts very clear for you.